Okay, so at this point we're going to combine kind of all of these ideas and we're going to figure out how to actually perform a significance test. So we can do these in a few steps. The first thing we're going to do for all of these is just start by writing our null and our alternative hypotheses. Second, we'll just choose a significance level. So like I said, that's based on a researcher, so we'll just choose what we wish for that. Okay, third, we'll take a simple random sample and find X bar. Okay, so for this, we're just going to pretend like we took a simple random sample, but it will be given within the example. Okay, and then we're going to find the standard deviation of the sampling distribution. So we're just looking at our adjusted standard deviation. Okay, then we'll find the test statistic, which will help us find the p-value. That's what we did in the intuitive examples. And then finally, we'll compare a p-value to our significance level to figure out if we will actually reject or accept the null hypothesis. Okay, so I'm going to go through this process in example 5, and then I'll do a couple more examples after this as well. Okay, so example 5 says, the average hours of television watching in the US from a recent survey is 2.983 hours each day. Okay, I think that the average for BC students will be lower. All right, so first, making our hypothesis. We're hypothesizing the average is 2.983 hours. Okay, we're given that. We say we think the average for BC students is lower, so we're going to say, okay, we think we're looking at something lower than this. Okay, assume that the standard deviation for all BC students is 2.5 hours and that their hours of TV watching are normally distributed. Okay, so on this, we still need to adjust the standard deviation because we're using it as a predictor. So we still want to adjust our standard deviation, adjusted standard deviation, and that's going to be 2.5 over. Okay, and then down here we see our simple random sample is 100, so we still need that over 100. So we're still working with the 0.25 on this one. Okay, so anyway, we take a simple random sample, so we're pretending like we did this. We took some simple random sample of 100, okay, and the average amount of TV watching for this sample was 0.95 hours. Okay, so that tells me that my X bar is going to be 0.95 hours. Okay, find the test statistic. We already did this in the intuitive example. So remember from the intuitive example, this was z equals 0.95 minus 2.983 divided by 0.25. When we did that, we got a large standard deviation of negative 8.132. So we did this already. Okay, we already found the p-value, but I can do it again. So I knew from before the picture I was looking at was something like this. I had 2.983 here. I had 0.95 here, and the p-value we're finding is the less than 1, so it's that piece. So you have p-value, we can just say even p-value if we want to. It would be equal to 0.5, so all of this, minus, and then we rounded this up to 0.5, which was 0. Okay, so describe what the p-value tells us in the situation. Use a sketch in your description. Well, I have a sketch up here, and basically what this tells me is my sample mean, okay, so 0.95 is really far away from my population mean. Okay, this probability is so tiny that I'm pretty sure my sample mean has to be way far away for this line to be moved over so much that my area here is so small, or about 0. Okay? And next piece, does this provide evidence that BC students really have a lower average than the nation? Okay, well, yeah, we can see that it's very unlikely we would get an X bar to be at or lower than 0.95 if the mean really is 2.983. So we would say yes, it's highly unlikely. Okay. The population mean is really 2.983 if our sample is so much less. We could say something like that. Okay, but of course we can look at this quote unquote more mathematically. So thinking about this, does this provide evidence that BC students really have a lower average than the nation at a 5% level? Okay, so at a 5% level. Okay, that's telling us alpha is equal to 0.05, so this is our significance level. Okay, so we would say since 0 is definitely less than 0.05, okay, this does provide evidence. So what we would do is reject, this is supposed to be H naught right here, we would reject we reject our null hypothesis. So since 0 is less than, okay, alpha, this is my p-value. Since my p-value is less than my significance level, we would reject H naught. Okay, so we're basically going through the same computations we did with the intuitive examples, but now we're just naming some specific significance level and saying, all right, if my p-value is less than that significance level, then I know I'm going to be rejecting the null. Okay, next pieces of this. So this is just the same example, kind of continued. Okay, so does this provide evidence that BC students really have a lower than average than the nation at a 3% level? Same idea. Since 0 is less than 0.03, that's our 3% significance level, then yes, it provides evidence that BC students really have a lower average, and we would reject that null hypothesis. Okay, at a 1% level, same thing. 0 is definitely less than 0.01, so we're still going to reject H naught, and that does provide evidence that BC students really have a lower average than the nation at that level. Okay, so on this, that's what it's going to look like if we have less than. If you read through example 6, it's also hypothesizing lower, so I'm going to have you practice that one on your own. It's the same process. You might conclude differently, but the process looks the same. So you're going to practice example 6 based on your example 5, the one that I worked through. Okay, and then if we look at example 7, we see that's also lower, so I'm going to have you practice that because the technique is going to be similar. Okay, but we are going to look at example 8 together, and just to condense the videos down a little bit, because it's hard to load them when they're large, I'll just turn that into a new video.